Ashley Escobedo, what did you write?
The answer?
Yeah, so what do you think this is? Chatty McChatter? Okay.
Well,
Ashley, what do you think these twos represent?
they multiply with the other two.
Awesome. Excellent hypothesis. What did she say?
I think they multiply with the other two.
Awesome hypothesis. What about you, Michelle? It's okay, just throw something out there. There is no wrong answer because I've taught it to you today. Awesome. Right? Maybe it has something to do with the oxygens. Probably. Okay, so this is from balancing chemical reactions. The way you fix chemical reactions and equations that do not validate or do not fit into the law of conservation of mass is that you add coefficients. So according to the law of conservation of mass, each of these represents atoms.
I get it.
What's the difference between an atom and a molecule? Can someone volunteer? Go for it, Miguel.
Molecules are made out of atoms.
Exactly. So if I'm dealing with water, that means I have hydrogen atoms, a hydrogen atom, an oxygen atom, and another hydrogen atom. When these combine and bond together, all of a sudden I have a molecule. So what the coefficients represent is that the coefficient represents the addition of a molecule. So prior, without this 2, I have 1 water molecule. It's better here, right? Before I add the coefficient, I have 1 water molecule. When I add the 2 as a coefficient, all of a sudden I'm adding a second water molecule. So how many hydrogens do I have?
2, 4.
4. Right? I have 1, 2, 3, and 4. How many oxygens do I have?
1, 2.
1,
Oh, 2.
2. Right? An easier way to do it so you don't have to draw it out each time is that it's going to be the coefficient times the subscript. And remember, if there's no subscript written, it's a 1. Okay, so the coefficient times the subscript, that means that we have 2 times 2 is 4. That means we have 4 hydrogen molecules. 2 times 1 is 2. That means we have 2 oxygen atoms. Yeah, definitely. So, we have a coefficient. Okay? When there is no coefficient written, we assume it's a 1. Just like in math. You don't have to write 1x, you just write x. When we add a coefficient, when we add a 2, that means we're adding another molecule. So when we add the 2 as a coefficient, we're adding another water molecule.
To the 1.
So now in this equation, instead of just having 1 water molecule, we have 2 water molecules. Okay? So in order, an easy way to figure it out, instead of having to draw out everything, because we learned last chapter that Lewis structures are sometimes irritating. Right? We can just do basic multiplication of the distributive property. You're going to take the coefficient, multiply it by the subscript, and that's the number of atoms for that product. So 2 times 2 is 4. That means we have 4 hydrogen atoms. 2 times 1 is 2. That means we have 2 oxygens. Okay? I have another slide for you visual learners, so don't you worry. I haven't forgotten. This is for those of you who learn best writing things down. Now we have things for visual learners. So if you look at the page, you should have this picture. Please label the coefficients. And you should have space to draw out all the molecules. So, because this oxygen does not have a coefficient, how many reactant oxygen atoms do we have?
2.
And why 2, Gio? 2 oxygen atoms on the reactant side. Okay, how many reactant hydrogens do we have? 4. And why 4, Nita? How many reactant types? 2 times 2 is 4, right? 1, 2, 3, 4. We have 2 hydrogen molecules. So they add together and that's 4. How many product hydrogens do we have? And why 2, Linda? Why do we have 2 product hydrogens? Do we have 2 product? Go for it, Linda.
No, there's 4.
There's 4. And why 4?
2 times 2 is 4.
2 times 2 is 4. 2 times 1, so how many product oxygens do we have? Good? Okay, so this is what I'm seeing on your faces right now.
Oh, I was about to say something really stupid.
Thank you for catching yourself. So, this is what I want to see on your face. We got this, okay? It's going to be a little bit irritating, it's going to be frustrating, but we got this. And it's hilarious.
Linda, you and your me.
So funny. Okay, so let's try this out. I'm going to give you a minute. See if you can figure it out for yourself while I write it down. Yeah. Huh? Oh, I guess. Wait, yeah, let me write it down first, and then I'll come to you. Thank you for catching yourself again, periodic table. Nice job. Catching yourself. Yes.
No.
Impulse control.
I wasn't going to regret that. You're going to regret that.
That you would have regretted.
I was about to say something really racist.
Yes.
No, Jose, I did it for like
Get the hell away from me. What the
I did like long time ago.
On top of it,
Ha!
no.
It's
2-1.
Oh! Is it what? Is it what?
Let's learn each other.
No, it's not.
Ashley, you have white on.
Hey, say that.
Colombia? Wow.
Okay, people. Ready?
Dude, I think it is there.
Okay, picture.
Okay, yours is the one that's right.
Okay, I spot my little eye. Ashley has the head of sitting in her seat. She is ready. Alright, Johnny's sitting in his seat and he is ready. So is Terry. Okay. So, I know some of you got the right answer. I'm going to walk through this because I think it's important that people hear a full explanation. Okay. So, how many reactant zinc atoms do we have, Victor? Right now, without changing anything. 1, perfect. How many reactant hydrogen atoms do we have, George? Perfect. How many reactant chlorine atoms do we have, Daisy? Perfect. 1. Now we're going to move to the product side. Right now, I'm just keeping score. So, how many product atoms do we have, Annie? Perfect. Sorry, couldn't hear you. How many product hydrogen atoms do we have, Dulce? Huh? chlorines do we have, Kimberly? Okay. So for someone, because I know the people who have already figured it out, so I'm gonna ask you just to pause for a second. So, what now? If we know, do the zincs fulfill the law of conservation of mass?
Yes.
Do the hydrogens?
No.
Why don't they?
Because it's not adding up to the product.
There's two hydrogens, right? Two product hydrogens versus one reactant hydrogen. So it does not fulfill. And neither do the chlorines. So where should we start?
Hydrogen.
Well, why would we not start with the zinc?
Oh,
It's already fulfilled. So let's start off with hydrogen. So remember, if there's nothing written there, it's assumed to be a 1. Should we start with the reactant hydrogen or the product hydrogen? Why?
Because it's what you're gonna get on the other side.
Right? Because we want to match 2 and product already has 2, so we're going to want to add to the reactant. So let's add to the reactant hydrogen. Now, what's our new levels of reactant hydrogen? TJ. What's our new levels of reactant hydrogen? Oh, 2. Right, you're going to need the coefficient times the substrate. Nice job. Now, what's our new levels of reactant chlorine, EJ?
2.
EJ.
Sorry.
2. And how did you get that? Yep. Subscript times the coefficient. Coefficient times
So
the
it's so they have to multiply with like with the atom, right? So it has to like all one that we have to multiply with this one, which is 1.
Yeah, exactly. So, are the hydrogens fulfilled?
Yes.
The chlorines? We are done.
Made it.
Okay, ready to try the next one?
Yeah.
So, before you get started, this is my tip.
If you start with oxygen, you're gonna have this bad.
Yeah. So, just as a general piece of advice, try and keep oxygen last. It's not gonna. That's not gonna be true in every instance, but in a lot of times, starting with oxygen kind of gets you into trouble. Okay?
Can it be in the middle?
Huh? So here, you'll see what I mean. Like adding to the oxygen first tends to complicate it. So add to another one.
No, but I'm saying, what if we do oxygen first and then oxygen?
Okay.
We're all ready to start.
Okay, so work with your group. See if you can figure it out. If you already understand this concept, feel free to move on to the homework.
Can you say his joke now? What is it?
Oh, miss, I got a joke.
That was Satan. I mean,
I already got corny on a joke. Yes, guys, I'm on it.
It's on.
Korea, dude.
You know he wasn't on the track. He was a substitute.
No, because you was multi-science.
What she did, she was on the
Stuck in the middle.
No, I'm seriously. So, but this will be fun.
Wait, so they speak?
You not passing.
I know they don't class, but they don't speak like
Do this
that.
one first.
I mean, I didn't know
Focus.
this.
Focus.
I just did.
You got this one out. Do it.
These aren't bad.
Hey, you've got 30 seconds left. Right.
Miss Lindo.
I did this because it makes
You get it? Sit on it.
No, because we never call.
negative positive.
Okay, hands up once. If you can hear me, give your partner a high five. If you can hear me, point to me. If you can hear me, point to the people who are not following directions. If you can hear me, point to me. Okay, so I did something wrong here. Okay? Take a minute and I want a hand. Once you see it. What did I do wrong? Go for it, Miguel. Oh, wait, enter it.
I see it.
Okay. Go for it.
Because you have an oxygen, two oxygen and then one oxygen over there, so it has to be three oxygen.
Okay, so does anyone else see it?
No.
Yeah, I did. Yeah.
What? Okay.
That's what Linda said, yeah.
One oxygen is there.
I have two oxygens here plus one oxygen here.
That equals 3.
So it should be 2 plus 1 equals 3.
Oh, we gotta do the.
But either way, should we just vote into 3? Oh yeah. Right? 3. Okay, I'll come to you later. Okay. So are the nitrogens okay?
No.
Are the oxygens okay?
Yeah.
Are the hydrogens okay?
Yes.
What should we start off with?
Nitrogen.
Nitrogen. So, should we add to the reactant or the product side? I'm going to choose someone Christian.
Should we what?
Should we add to the reactant or the product side?
We can't add to the product.
Reaction because it's reaction makes the product side.
Wait, yeah. Well, look at the numbers, right? We have 2 on the reactant side, and we want 2 on the product side, so where should we add to?
To the product side.
So, now, what is our new levels of product? 4 hydrogen.
4, 2, 6.
Right, and how do you get 4 for the hydrogen, Priscilla?
2 times
2 times 2, that means we have 4. Oh, right? So 2 times 2, that means we have 4 hydrogen atoms. How many nitrogen atoms do we have, Daniel?
6.
2, nice job. 2 times 1. And then how many oxygen atoms do we have?
3.
2
Oh, wait, no.
times
3.
3
Only
is
6.
6. So let's take a new count. Okay, we're going to count. Nitrogens are okay. Oxygens aren't. Neither is the hydrogens. Now, I need you to stop and look critically at this.
It's half.
Okay? If we want to impact the oxygens and the hydrogens together, where should we add to next? H2O. Right? Because if we add to H2O, we're going to hit both the hydrogens and the oxygens. So let's add
We're going to have a test on this?
Oh,
Yeah, why would you say that?
Okay, great time. You guys will be laughing. It'll be easy because by the end you will be mastered that. So, how many product hydrogens do we have now? 4. And we have 2. Now for the oxygen. For the oxygens, we have 2 given by this molecule, and then 2 given by this molecule. So Victor, how many do we have? How many total oxygen atoms do we have?
4.
But, okay, so now the hydrogens are okay. We just need to fix the oxygen. What can we do to fix the oxygen?
Added 2 in front of the oxygen.
Perfect. So when we added 2,
I don't last a day.
what's our new numbers of oxygens, Johnny?
I don't know.
You got this, right here. I'm gonna help you.
I
Oh, okay, come on, focus. I'm gonna help you.
What's 2 times 4,
Should
Johnny?
I help you?
4. God damn.
4, perfect.
You stupid.
Plus, right here, Johnny, 2 times 1. 2. So what's our new numbers of oxygen?
Johnny.
Nice job. So Johnny, does it fulfill the law of conservation of mass?
I guess so.
Johnny.
Okay. Can I have thumbs? I got this. You're speaking Chinese. Please stop. And I just need practice. Okay. Okay. Thumbs, please.
Got it.
So I know what to do.
Got it, and I just tried to.
Perfect. Okay. We're gonna skip.
No, the middle of the middle.
What?
Nobody raises their hand. You see how it's not like this?
Yeah, I don't want to drink right?
If she wants to know what to do next. We're skipping around the world. Okay? We're gonna go right to homework because I want to give you time to work on your projects. You're gonna have 10 minutes to do the homework and then 30 minutes to work on your project. Okay? So right now you must work on the homework for 10 minutes. Ashley, can you come explain? I'm gonna come and explain.
Because I'm skipping it. I got it.
Okay, good practice. You guys got this. Yeah, I know.
No, we're talking about the second one. What?
Okay, keep track. So how many seconds do you have?
No, but like, you act like you
This is like this.
So we're keeping track of the number of molecules on each side, right?
Everything goes like.
I know it, you're right.
So how many CUs
So
do
it
we have?
is.
I got it. It's 6.
How many O's do we have?
1.
Yeah, we're gonna add
Yeah. It's better to be ready like that.
So think of it this way. When I added 2, I added 2.
3, 2, 2.
I'm adding 2 of these. When I'm at a 1, so I added 2.
3, 2, right?
Yeah, it's 4. Why? Because there's 4 oxygens. And then it's 2.
Multiply this coefficient by the subscript.
3, 4.
2.